quick review here on some things. And again, any back and forth, if there's questions as we go, let me know. So if we're simplifying, this was the first part of the quiz that you saw. Your first job, of course, is to factor. I'm even going to write that. Factor. Because if some of you go through and just start canceling x cubes and x, you can't do that. They are bonded by plus and minus. They're strong bonds. Unless they're identical, you can't do anything yet. So if when I go in and I find the biggest number that divides into both terms, right, and the smallest exponent, if you want to write something like that down, smallest exponent, you can. I mean, hey, nothing illegal about it. And then you go back and say, hey, if I were to multiply this and try to get this, well, I mean, I already got the 6. I got 2 x's. I just need one more. And for this one, you're like, Hardy, I got everything, so I'm not going to write anything. Not quite. Yeah, if they're identical, you still want to put something. So let's put the plus 1 and get that done. And we do the same thing down in the denominator. Biggest number, smallest exponent. Ooh, I see something coming. This ought to be interesting to see how we handle this. I got 1x. I am talking about the difference of squares. Because I need 2 more to get to 3. And this, the only difference is, to get from 2x to negative 2x, I need negative 1. Nailed it. Yeah, this is a difference of squares. And again, you have the help sheet. It is legal to use it. So, let's rewrite. So again, if I'm referencing my help sheet here, there's the difference of squares. Perfecto. X plus 1, x minus 1. Now, those are identical. I can zap those. So now comes the final question. These are not in parentheses because there's no plus or minus. I can reduce this stuff on the outside still. So, 6 divided by 2 is 3. The bigger number's in the numerator, so that's where my 3 goes. Bingo. 2 minus 1 is 1. 3x, that's in parentheses. Don't do it. Don't do it. There it is. And we're set, and we're ready to go. So again, just make sure when you're doing these that you're giving yourself that chance, that opportunity. I'm just looking at one thing. Yeah, I'm only going to do one with slide and divide because we've seen that a lot. And So, first things first, how do I want to do this? Let's do this. Split those up. Okay, slide and divide. Multiply the 4 down to the end. Now it's a regular old multiply and add problem. Okay, let's see. Multiplies to a positive. They got to be the same sign. There it is. 6 and 6. But don't forget about your 4 from over here. And, because you're like, well, Hardy, that doesn't go in even. I'm just going to move the 4 over. Don't do it. 6 divided by 4, math enter, is 3 halves. Sorry that I got a little squished there. And after you reduce it, if it's still a fraction, and I'm just going to write this back up at top because We're getting way too crushed down here. So the 2 goes to the front. It's not under the 3 anymore. And I get that in there. And so then I do it one last time. $54. So let's see. No, that's right. Oh wait, no, it's not. Right there. So let's see. The negative, we're going to get one of each sign. Now, you're right. Normally we'd think 9 and 5, but 9 and 5 is not going to work because, 9 and 6, sorry. 8 and 7 is 56, but I like the track you're on. Now, wait a minute.
Oh, 18 and 3.
Ooh, very nice. Very nice. 18 and 3. Still on the chart, but man, that was a ways out there. Okay. Divide by 2. If it goes in nice, great. If it doesn't, back to the front you go. Ooh, excuse me. Thank you. The identical sets of parentheses we can cancel out, and off we go. Over half of what we were doing yesterday is that type of stuff, whether it's multiplying and dividing or simplifying. And so, what we'll do here, because like I said, I'm not going to hit up every single one of these. There's a multiply and a divide. We'll do one of each of those, because the main issue is adding and subtracting, to be honest. So that's where we're gonna make our focus today. Okay. Multiply and divide. Ooh. Here, the issue on the quiz, we didn't get the biggest one out, is what tended to happen here. So if I'm looking for 42 and 24, it might be possible. Okay, there's 1, 6. Can we do better than 6? 42 and 24. It looks like 6 is as good as it's going to get. Yeah, 6 is as good as it's going to get. Okay. So 6a. Because again, smallest exponent on a variable. And then we just divide. 42 divided by 6. 2 minus 1. Yep. And then minus 24 divided by 6 is 4. And I get the first part. And then I'm like, okay, 21 and 12. 21 and 12 looks like a 3 to me. 21 divided by 3 is 7. Need the A. Negative 12 divided by 3 is negative 4. Hey, that's sweet. We already see something's going to cancel. 3a and 9, anything in common? 3. Divide that out. A minus 3. And what about the denominator? 6 and an A. Biggest number in. We need an A. 24 divided by 6 is 4. Okay.
Those are the same, like the 6a and 6.
They are. This whole thing is the same. So we'll just, we'll zap all that.
Why'd you zap the a?
I don't know, because I'm doing silly stuff that I shouldn't have. I got too excited about the 6a and I decided to zap a plus 4. We can zap the 3s.
And that's it.
Yeah, I over-zapped over there.
A minus 3 over A plus 3.
You got zap at.
I did get zap happy. Yeah, don't zap those A's. Can't do that. Those are bonded together here. So we make sure. Okay. One last thing to play, and it's nice to see the factoring again. Let's do this to all these so we're not tempted to do bad stuff. The divide means we're doing flipping. So, W squared minus 81. Very nice. Perfect square. So W plus 9.
Keep that on top.
Yeah, that's going to stay. Yeah, the first fraction stays right where it's at. Now, let's do a little side work here on the second one. I'm going to purposefully try and write a little smaller than I normally do so we actually can fit this. Okay, so once I slide my 4, I got W squared plus 27W minus 28. Wait.
28.
So, yep, two numbers that multiply to a negative. So, multiply to 28 and add to 27. Yeah, the 28 and the negative 1 here is what we got working. Again, if I got to take a minute, I got to use the chart, I got to play in the calculator, that's all okay.
Throw that under. Oh, yeah.
So 28 divided by 4 is 7. 1 over 4, that gets me a decimal, but that is the simplified form of it. So 4W minus 1. So we've survived fraction numero uno. This is now the top of your fraction. W squared plus 11W plus 28. So let's see. Everything's plus. That's nice. Multiplies to 28 and adds up to 11. 7 and 4. Progress. We go to the denominator to wrap her up. Yeah, so this is now my denominator. 1 plus 1 minus. Multiplies to 36 and is 5 apart. Negative 9 and 4. And now we get to do the fun part. Again, you can cancel diagonally. You can cancel numerator, denominator. Diagonally. Diagonally or vertically. We just can't go side to side.
Yeah. Okay.
So either of those other ones are okay.
So I couldn't do like across the multiplication side to side?
Yeah, like if this was W plus 9 and this was W plus 9, I can't cancel this way. No.
That's what I thought.
Yep.
That's W plus 4 and W minus 9 on the bottom of the second one, right? I
Yes.
just can't tell what number.
Yeah, I started crossing out things.
So we're stuck with that.
So we're stuck. Now, when you're adding or subtracting, okay, this seemed to be the sticking point. We'll start with 7. We'll kind of see. If your denominators are the same, don't mess with them. Just leave it alone. Which then means all I'm looking to do here is add up my like terms in the numerator.
So
20k plus 10. Now, take a look at both the numerator and the denominator. Can you factor anything out in either? Yes. Biggest number that goes into 10 and 20? 10. So we're going to divide each of these by 10. What about the denominator? 4. Oh, what a coincidence. 2k plus 1. Can I reduce 10 over 4?
5 and 2.
5 and 2. And or a little math enter. Okay. So again, just trying to get you to think a little bit as far as that goes. That wasn't the biggest problem, though. So again, let me flip. Yes, but I'm gonna hand pick some stuff now. Because there's certain things.
Do we have any practice?
Well, because the subtraction one next to that would just be the same because they have the same denominator. And it'd just be subtracted.
Yep, and we're gonna see a subtraction one here in a minute. We're gonna see 2 of them. Okay.
I think that's the only thing I did bad on.
These last 3 are almost identical to the ones that messed people up on the quiz. So, get ready, because this is probably going to help you out the most. So, stick with me, even if you did good, stick with me, help the group out. 12 and 24. So basically, we're going to write this out. If you start counting by 12s and 24s, it doesn't take long for you to see that they're both in the same column. Okay? I could, if I was using my multiplication chart, I could start at 12 and I could start at 24 down here, and you just start going across until you see the same number. Okay? That's another way to find it. So this is going to be 24. And since this has a y, I need that. We'll get there. So when you're looking for a least common multiple in the denominator, what you're basically doing is I'm going to start counting by 12s and by 24s until I see the same number show up in both lists. So if I start counting by 12s, 12, 24, 36, 48, and I do the same thing with 24, 24, 48, I already see there's my first number in common. Yeah.
Why do we put it in the denominator?
Because when I go to build my numerator, because I need these to be the same, I'm going to have to build this piece up so that equals. Like if I'd have kept these both as 12, you can't multiply 24 by a whole number and get to 12. So it's always going to be bigger on the scale as we're doing this. And like I said, worst case scenario with those, take whatever numbers that you're looking for and just start going across until you see the same number show up in both. That's the number you need in the denominator, is what we're basically doing. If we need to do a couple more of those in a bit separately, we can.
I just don't understand that.
Gotcha. And then if we have any variables, we take those. We'll do parentheses later. But here's your challenge. What do we have to multiply 12 by to get to 24? 2. But we've already got the y, okay? So we've got the y, we can check that off. I do not need to put another one up there.
So if you get 24, you can multiply 12 by 2, so that's why you put that in the numerator?
Yes. And then we're doing the same thing here. I've already got the 24. I don't need that. But I didn't check off the y. So I have to put the y in there. We're building the numerator. And so now that we have a common denominator, 3 times 2 is 6, 9 times y is 9y, and we'll do what we've normally been doing for every other problem. Can I... The check mark to me is a way that I can look because I'm comparing my old denominator to my new one. So whatever I already have in my old denominator and I see it here, it just means I don't need to put another one of those up there. That's just kind of a visual for me that I do. Anything in common in the numerator? 3. So if I divide a 3 out, now there's more stuff outside. Yes, I can reduce this more. If I go to my calculator and I do a math enter on 3 over 24, I get 1. That's a 1 hanging out here. Yeah, just did math interrupt the 3 over 24. So that was the stuff that was free and available. It wasn't in parentheses. It wasn't accounted for. That's the type of stuff that we're trying to get you situated with here. So actually, I'm going to come down to these. We'll come back here. I want to do some shorter ones so you can kind of see this at work. Okay. I'm going down my checklist of things. In the denominator here, okay, there are no numbers hanging out on their own. The only one's in the parentheses. So that's not what I'm talking about. I do have a single variable.
Wait, in the red in the top question that you just did, all you did was simplify 3/4, right?
The 3 over 24, yes. Everything else stayed the same. Yep. So single variables, yes, I have an R. Sets of parentheses, every single different one you see would be included. So in this case, it's just R plus 6. That's the only one I have. Those R's are not the same. Don't cancel yet. It's tempting. You're like, I want to cancel those R's. Don't do it. You're comparing the old denominator to the new. I've already got the R plus 6.
Do you just combine the denominators?
In this case, it looks like I just threw them together. But in reality, that single R would be its own step in building a denominator, and this would be 2. If I'd have had multiple single variables, I'd be looking for the largest exponent. But I only have that one.
So you did just smash them together.
In this case, they are just smashed together.
I was just confused how you got the denominator on this one. Like I know the next one above you counted the numbers to get to the same.
Yeah, we're always, when we're doing these, we're always, and I had this up before, so we're looking for numbers that are just out in front first, like we did with the 12 and 24 up here. We played with that. Then we look for single variables where there's no plus or minus involved. And if we see those, we take the one with the largest exponent. Well, here, that's the only one that's a singleton. So I needed to have that. And then finally, that's when we go looking for the sets of parentheses and we put those in. And I had one of those. So that's the reasoning behind smashing them together. And once I have that, then again I can start the comparison. The R's check. I didn't check off the R plus 6.
Yeah, you just put the R back up top left one because you got the R from the bottom.
Yep, that one.
So you just you went diagonally. You just added back to the numerator.
The reason I did this is what I'm actually doing here. Take this back out for a minute. So if I'm trying to go from R over R plus 6, the original, and I'm trying to get to this new one that has a denominator of R plus 6, what do I have to multiply? Forget about this for a minute. What do I have to multiply this by to get to this? I need to multiply by R. So whatever I do to the denominator, I have to do the same thing to the numerator.
Okay.
So that's where that's coming from.
I get it.
Okay? Ooh, I wish I would not have used red on there. Okay. So I've got R squared. This minus goes with your 1. So this is a negative 1 that you're distributing. So I'd have negative 1R and negative 6. Now, if you got to here, you've got a majority of the points already. But do we want to make sure? Do we want to see if we might be able to do any more? Let's check. Let's try to factor. I don't know if I'm going to be able to factor or not. Well, we're going to have to see. Oh, let's see here. R. Okay. Multiplies to a negative. One of each. So what multiplies to 6 and is 1 apart? 3 and 2. Hardy, nothing cancels. It's true. Nothing does cancel this time. Because that r is hanging out on its own. There's nothing to cancel it with, and none of my parentheses are the same. So I can't do anything else. That's just done. That's the trickiest part. I admit it with the rational functions with adding and subtracting. Oh dear. So I look at this next one. Where'd my little checklist go? Let me get my little checklist back out here. Do I have any numbers hanging out in front? No. Do I have any single variables hanging out in front like my r here? No. But I do have these parentheses, and they're different. So I got to have them both. That's the denominator. Yep. Yeah, I'm not going to multiply it back out because that'd make it harder for me to be able to see what I need. Because now that it's in its factored form, when I go look to see what I need, and I've checked off my h minus 2, I need the h minus 5. And when I go here, I've got the h minus 5. I need the h minus 2. Whatever we don't check off in that new denominator, that's what needs to go up in the numerator. That's why I like using colors for this too.
So what decides like which one goes? So what decides that like the h minus 5 goes by the 3 opposed to the 5?
Because here,
yeah,
it all depends on when we're going from old to new. I already have the h plus 2, so I wouldn't repeat it.
I see now.
Yeah, it just goes either way.
Because you already have that in that fraction.
Correct. So we do our distributing. And if I try to factor my numerator this time, nothing goes into 8 and 25. So that one's just done. Nothing happened. Nothing crazy. Nothing too wacky. And so the last thing you can run into, and I don't want you to think it's bad just because it's larger. I'm going to make sure we touch them all, because this is going to even show up in the next quiz area. If you can factor something before you start, you should. Especially if it's in the denominator. So let's start there. I think... Okay. Multiplies to a negative. One of each sign. Multiplies to 27 and is 6 apart. Oh, let's find me a 20. There's a 27. 9 and 3. That works. 9 and 3. Okay, so the old one, I'm just going to cross that out. I'm not messing with the numerator right now. I want to get things built. So again, we're just looking at the denominator. No numbers in front. No variables hanging out by themselves like they were in number 9. So every different set of parentheses I see I'm going to use. Notice I didn't do p minus 3, excuse me, p plus 3 twice. I only need to use it once. And the reason I stress that is that just made my heart rate come down a little bit. Because I'm like, okay, check, check. I checked off everything. I don't need anything else in the first fraction. It is fine just the way it is. Second fraction. I've got the p plus 3.
And you use the p plus 3 and the p plus 9 because the p plus 3 and the second one, it has the second one has the p plus 3. So you use
it's the exact same one. Yep. And so I didn't check off the p minus 9, so we're going to do that. So when we go to wrap, I appreciate your patience today, and I think it's going to pay dividends for some of you tomorrow here. Oh, we got to clean this up, though. Okay, again, watch your sign in the middle. This is minus. So this is like you're looking at a -4 that you're distributing through. Why did I? Well, that's a 1. Okay. Negative times negative is positive. Okay, let's just clean up this numerator, because we be running out of room. Okay, p squared. 2p minus 4p is negative 2p. Negative 51 plus 36, oh dear Lord, is negative 15. Yeah, I'm realizing things. I'd be so happy if y'all would get there like on something like that tomorrow. But I'm noticing I think it's factorable. So I'm going to try. Because I'm crazy like that.
When adding and subtracting exponents don't matter, right? Like, if it says, or I mean, like if you have a 4p2 and a 3p2, it'd be 7p2.
Yes. Yeah, we're not messing with exponents at all when we're doing that.
It would be p4.
Right. Oh boy, let's see. One more time, people. We're almost there. Multiplies to 15 or 2 apart. 3 and 5. Those go away. There's my answer. Okay, I'm going to be straightforward here with this. I can't force it. I can just, in knowing already what's on the quiz and seeing the stuff that was there before, the only thing I can tell you, I got to get one thing before I say this. Okay, let's do this. I got to bump this up a little. Okay, if you're going to do on pages 3 and 4, here's what I have to stress to a majority of you. At a minimum, okay? There's the adding ones. That's where the biggest issue was. Do them. If you do feel like you're kind of with the other stuff, get these back in. But those, I'm serious. If you work through those, the keys are online. Try them out, check them, go back through. If you do that, when you get your quiz back tomorrow, it's going to look a whole lot more doable than if you don't.